right. Arithmetic, right? Fundamental theorem of arithmetic, right? Let P be a prime number. If this P divides square of any number, for suppose if P divides a square, it is prime number. If this P divides a square, P, we can conclude that P also divides a, right? This is the fundamental theorem of arithmetic. Depending on this theorem, we can prove irrational numbers as irrational number using contradiction method. Okay, now we will discuss of proving root 2 as a irrational number, right? Even though root 2 is irrational, we will assume that root 2 as rational and we will prove that as irrational by using contradiction method. We know that every rational number is in the form of a by b, where a comma b are co-prime integers and b should not be equal to 0. It is our definition according to rational numbers, right? And we will take this definition into this question, and look at here, this co-prime integers plays major role for this question, for proving this question. Look at here, co-prime integers means a comma b has highest common factor HCF as 1. It does not have common factor more than 1. Co-prime means, the meaning of that one is, co-prime means a comma b has HCF as 1, highest common factor as 1, right? By depending on this condition, I will prove here root 2 as a irrational number, right? Right, now I'm assuming let as, look at here, let us assume root 2 as a rational number. Root 2 is not as, root 2 is a rational number, right? Now if it is rational number, it can be in the form of a by b, right? And then a by b, right? A comma b are co-prime integers where b not equal to 0. B should not be equal to 0. And then I'm squaring on both sides. That will become 2 equal to a square by b square. Square root gets cancelled. 2 equal to a square by b square. Clear? And then here I can write b square equal to a square by, I will transpose this b square this side, this to this side, and here 2 divides 2 divides a square, then 2 also divides a, right? Here 2 divides a square, 2 also divides a, by using fundamental theorem of arithmetic, which we have discussed before. Fundamental theorem. Arithmetic. Right now, and therefore I can, if 2 divides a 2 is the factor of a. Right now again let a equal to 2c. I will explain why I'm assuming a equal to 2c. Right, we know that b square equal to a square by 2, right? B square equal to a square by 2, right? And then I'm not taking instead of a 2c, b square will be 2c whole square by 2, right? B square can be 4c square by 2, 2 ones and 2 times. I can simplify this as b square equal to c square, then c square equal to b square by 2, right? Transposing this 2 towards this side. And here we can say that here we can say that b square divided by 2, right? Or otherwise 2 divides b square. 2 divides b square. That means 2 also divides b, right? 2 also divides b by using fundamental theorem of arithmetic, which we have discussed in the earlier cases, right? Therefore 2 is the common factor for 2 is the common factor for 2 is the common factor for a comma b, right? 2 is the common factor for a comma b. But we have, look at here, we have assumed a and according to our statement, according to our rational number statement, a and b should have HCF, highest common factor, as 1. But here we got a common factor as 2. But it is contradiction to our fact, right? What is that fact? Rational number, right? It is therefore a comma this, okay, otherwise we will write this as therefore this contradicts the fact that a comma b are coprime. Opposite, right? We have assumed as coprime numbers, but we have got those are non-coprime numbers, right? Therefore this contradiction has arisen. Contradiction has arisen due to our assumption. Since we have assumed root 2 as a rational number, this contradiction has, this opposite statement has arisen. That is why this contradiction is due to our assumption. Therefore our assumption is wrong. What is our assumption? Root 2 is rational. Then what is correct? Therefore root 2 is irrational. This is a proof for proving root 2 as irrational number. Next one we will discuss, next questions. Proving the combination of numbers as rational numbers. Sorry, rational numbers. Example 8. 5 minus root 3 is irrational. We have to prove this as irrational. Right. Let 5 minus, let us assume we will assume this as rational, is rational, right? Is rational, and if that is rational, we can write this as a by b, right? We can write this number in the form of p by q or a by b, where a comma b are co-prime integers and b should not be equal to 0. A also will not be equal to 0, but we will not mention that as separately. B should not be equal to 0. If b equal to 0, that value will be undefined, and if a also will not be equal to 0. Look at here, I am transposing minus a by b structure towards this side, supplies a by b structure towards this side, that will become minus a by b, and here you will get root 3, and in the left hand side we have 5 minus a by b, that will gives us rational number. Look at here, that gives us a rational number, right? Because if you take any value in the place of a or b, you will get rational number. If it is rational, it will also become rational, right? If it is rational in the left, if left hand side is rational, if left hand side is rational, right hand side will also rational, right? Then right if left hand side is rational, right hand side will also become rational, but we know that root 3 is irrational, right? LHS is rational for any value of a and b, for a and b, if 5 minus a by b is rational, root 3 is also rational, right? Root 3 also rational, right? But we know that root 3 is irrational, right? It contradicts the fact that root 3 is irrational, right? It contradicts the fact that root 3 is irrational. Why this contradiction has arisen? Due to our assumption. What is our assumption? This contradiction has arisen due to our assumption, right? This contradiction has arisen due to our assumption, right? That means, what is our assumption first? 5 minus root 3 is rational. That means our assumption is wrong. What is our assumption? 5 minus root 3 rational, right? What is right now? Therefore 5 minus root 3 is irrational, right? Now we will discuss example 8. Five minus root 3. We need to prove this 5 minus root 3 as irrational. First we will assume this as rational. Let us assume 5 minus root 3 is rational, right? 5 minus root 3 is rational. If it is rational, 5 minus root 3 can be written as a by b, where a comma b are co-prime integers and b not equal to 0. Therefore 5 minus root 3 equal to a by b, and I will take minus root 3 towards this side, a by b towards this side. 5 minus a by b equal to root 3. Clear? Look at here. For any value of a comma b, for any value of a comma b, 5 minus a by b is rational. If LHS value is rational, RHS is also rational, right? But it contradicts the fact that root 3 is irrational, because if LHS is rational, RHS will also become rational, but in the RHS we have root 3, right? We know that root 3 is irrational. It contradicts the fact that root 3 is irrational. Why this contradiction has arisen? Because of our assumption, right? This contradiction has arisen due to our assumption. What is our assumption? That is 5 minus root 3 is rational. Therefore our assumption is wrong. Then what is right? 5 minus root 3 is irrational. And next one you can do example 9, and we will move to the example 10. Example 10 is the most important question. Example 10 is the most important question for your 10th class board exam, right? Prove that root 2 plus root 3 is irrational, right? Right. Now we will discuss example 10. Example 10 is the most important question for your board examination. Every time it is coming, this question are the model question, same question you are getting in the board exam paper. But if you listen this question carefully, you can write, you can attempt any question. Here it is root 3 plus root 3, right? What is the first step? We will assume this as a, even though we know this as a irrational number, we will assume this as rational number. Let assume root 2 plus root 3 is rational, right? If it is rational, how can, how we can write this as root 2 plus root 3 equal to a by b, where a comma b are co-prime integers. B should not be equal to 0, even though a is also not equal to 0, but we will not mention that one. But same, next again we will find, we will do squaring on both sides. Squaring on both sides, we will get root 2 plus root 3 whole square. That gives us a square by b square. A square by b square, right? Here root 2 plus root 3 whole square means a plus b whole square, right? A square, a plus b whole square, a square plus b square plus 2ab, right? A square means root 2 whole square, b square means root 3 whole square, plus 2ab means 2 into root 2 into root 3. That will give us a square by b square, right? Root 2 whole square, root 3 whole square, 3 plus 2 root 3 into root 2 into root 3 will give us 6. That will be equal to a square by b square. 5 plus 2 root 6 will be equal to a square by b square. I will keep irrational number one side and rational number to another side. Right now 2 root 6 equal to a square by b square minus 5. Transpose this 5 towards that side, that will become minus 5. And 2 root 6 equal to a square minus, if you take LCM for the denominators, if you convert like fractions, you will get this value. And then again I will transpose this 2 toward the side, a square minus 5b square by 2b square. Look at here, and again for any value of a comma b in a square minus 5b square by 2b square, or any value of a comma b in a square minus 5b square by 2b square, the value is rational. If RHS value is rational, LHS value is also rational, right? But LHS value is, we know that LHS root 6 is irrational. LHS root 6 is irrational. This right? This contradicts the fact that it is opposite fact that root 6 is irrational. Why this contradiction has arisen? Why this contradiction has arisen? This has arisen due to our wrong assumption. What is assumption? What is our assumption? Is rational. Therefore, our assumption is wrong. What is correct now? Root 2 plus root 3 is irrational. Right? This is a proof. Right, now we will discuss example 9. Right, we need to prove root 3 root 2 as irrational number. Right, look at here. First, we will assume 3 root 2 is a rational number. If it is a rational number, it can be in the form of a by b, right? Where a comma b are co-prime integers and b should not be equal to 0, right? And now I will transpose this 3 towards that side, right hand side. It will divide whatever the numerator is there, and this will become 3b. Root 2 equal to a by 3b. Now for any value of a comma b, a by 3b is rational number, right? If a by 5 is rational number, root 2 is also rational. Why? Because equal symbol is there, right? Equal symbol is there in between the two expressions, right? Root 2 is rational, but we know, right, already root 2 is an irrational number, and this contradicts to the fact that root 2 is an irrational, right? Why this contradiction has arisen? Why this contradiction has arisen? This contradiction has arisen due to our assumption, right? That means our assumption is correct, wrong, right? This contradiction has arisen due to our assumption. Therefore, our assumption is wrong, and therefore our assumption is wrong. What is our assumption? 3 root 2 is rational number, right? What is correct now? Therefore 3 root 2 is an irrational number, right? Here first we have assumed 3 root 2 as a rational number, and we have proved 3 root 2 as an irrational number by using contradiction method, right? Now we will discuss exercise 1.4 first bit problems, right? We have to prove 1 by root 2 as irrational, right? We will assume first, let us assume 1 by root 2 is a rational number, right? If it is a rational number, it can be in the form of 1 by root 2 equal to a by b, where a comma b are co-prime numbers, co-prime integers, right? Co-prime integers, and b should not be equal to 0, right? I will do reciprocal here. It will become root 2 and it will become b by a, right? Look at here, root 2, anyway we know root 2 as irrational number, and here for any value of a comma b, b by a is rational number, rational number, right? Rational number. If b by a is rational number, root 2 is also will become rational, right? Why? Because equal symbol is there between that. If b by a is rational, root 2 also rational number. But we know already root 2 is an irrational number, right? Therefore this contradicts to the fact that root 2 is an irrational number, right? If it is contradiction to the whatever we have discussed here, if it is contradiction to root 2 is an irrational number, therefore why this contradiction has arisen? This contradiction has arisen due to our assumption. Therefore, because of our assumption only, this contradiction has arisen, right? Therefore, our assumption is wrong. What is our assumption? 1 by root 2 is rational number. What is correct now? Therefore 1 by root 2 is irrational number. This is the first question, right? And we will go to the next question. Coming to the second question, root 3 plus root 5. We need to prove root 3 plus root 5 as an irrational number, right? First, what is the first step? Root 3 plus root 5. We will assume, let us assume root 3 plus root 5 is a rational number, right? If it is a rational number, it is in the form of a by b comma where a comma b are co-prime integers and b should not be equal to 0, and squaring on both sides, right? If you do squaring on both sides, you will get like this, and then now if it is in the form of a plus b whole square, right? We know a plus b whole square equal to a square plus 2ab plus b square. Right now, a square plus b square plus 2ab, that will be equal to, here also we have square b square, right? It can be 3 plus 5 plus 2 root 50 equal to a square by b square. Right now, 8 plus 2 root 15 equal to a square by b square. Right, 2 root 15 equal to a square by b square minus 8, right? Now 2 root 15 equal to a square minus 8b square by b square, right? If you take LCM for the denominators here, right, root 15 equal to a square minus 8b square. What 2 is doing here? 2 is multiplying, right? If it transposes to this side, that will divide whatever the numerator is there, right? Clear? Now here in the right hand side we have a square minus 8b square by 2b square. In the left hand side we have root 15, right? Right. For any value of a comma b, a square minus 8b square by 2b square is rational. If it is rational, if a square minus 8b square by 2b square is rational, left hand side will also become root 15 is also rational, right? Right, but we know already root 15 is irrational, right? This contradicts to the fact that root 15 is an irrational, right? Why this contradiction has arisen? This contradiction has arisen due to our assumption, right? Right, that means our assumption is, because we have assumed that root 3 plus root 5 as root 5 as a rational number, we got this contradiction, right? Therefore our assumption is wrong. Then what is right? Root 3 plus root 5 is irrational number. Irrational number. Next question. We'll move to the next question. And 6 plus root 2. We need to prove 6 plus root 2. Now we will do, let us assume 6 plus root 2 is a rational number, right? Now if it is a rational number, it can be in the form of a comma b co-prime integers. B should not be equal to 0. And now I will transpose 6 to other side to equal to a by b minus 6. Root 2 equal to a minus 6b by b, right? If you take LCM for the denominator, right? Now here in the right hand side, for any value of a comma b, for any value of a comma b in a comma b, a minus 6b by b is rational, right? If it is rational, if a minus 6b by is rational, root 2 also rational number. But we know that already root 2 is irrational number, right? Right, therefore this contradicts to the fact that, what is fact? Root 2 is an root 2 is an root 2 this contradicts to the fact that root 2 is an irrational number. Why this contradiction has arisen? This contradiction has arisen due to our wrong assumption, right? Due to our assumption. Therefore our assumption is, assumption is wrong. Then what is correct? Look at here. What is the question? 6 plus root 2 is 6 plus root 2 is, therefore 6 plus root 2 is irrational number. Right, next one. Next we will go to the next question. What is that next question? We need to prove root 5 as irrational number, just like root 2. We will discuss that one. Right, let us assume root 5 is a rational number, right? Therefore it can, if it is rational, it can be in the form of a by b, where a comma b are co-prime integers and b should not be equal to 0. Co-prime means HCF, highest common, should be equal to 1 for a and b. highest common factor should be 1. Remember that thing. We will do this question depending on this. Right, I will do squaring on both sides. I will get phi equal to a square by b square. Right now I will go with b square equal to a square by phi. Transpose this denominator this side, this phi this side. Now here phi divides a square, right? Phi is dividing here. Phi is dividing a square by fundamental theorem of fundamental theorem of arithmetic. Fundamental theorem of arithmetic. If phi divides a square, phi also divides a, right? If phi divides a square, phi also divides a. That means phi is the factor of a. And now from this I will take let a equal to phi c. I will assume a equal to phi c and substitute a equal to phi c in this equation. Right, b square equal to phi c whole square by phi. That implies we will get b square equal to 25 c square by 5. 1 time 5 times b square equal to 5 c square. Now I will get c square equal to b square by 5, right? If we transpose 5 towards left hand side. Right, now here 5 is dividing here phi is dividing b square. If phi divides b square, phi also divides a, right? Sorry, b, right? If phi divides b square, phi divides b by fundamental theorem of arithmetic we have discussed earlier. And then therefore phi is the factor of b, right? Therefore phi is the factor of b. Now what I assumed, a comma b are co-prime numbers, right? If those are co-prime numbers, if those are co-prime numbers highest HCF will be 1. But here we got phi is the factor of a and b. But we have assumed the a comma b as co-prime numbers. HCF should be 1. But we got a comma b have factor phi as the factor. But this contradicts. It is opposite that a comma b have highest common factor as 1. Why? Because here we got factor phi as the factor for a comma b, that is more phi is more than 1, right? Therefore it is this contradicts to the fact that a comma b are co-prime, right? This contradiction has arisen due to our wrong assumption, right? Right, due to our assumption, right? Therefore, our assumption is wrong. What is right now? Therefore, root 5 is an irrational number. Right. Now we will discuss next question. 3 plus 2 root 5. 3 plus 3 2 root 5. We need to prove 3 plus 2 root 5 as a irrational number. We will assume that number as, let us assume 3 plus 2 root 5 is a rational number. But if it is rational, I can write it is in the form of a by b, where a comma b are co-prime integers and b should not be equal to 0. Right now, I will transpose 3 towards right hand side. A by b minus 3, right? Minus 3. 2 root 5 equal to right hand side will become a minus 3b by b if you equate that denominators, right? Root 5 equal to a minus 3b. If you transpose 2 towards this side, that will become like this, right? For any value of a comma b, a minus 3b by a minus 3b by 2b is rational, right? If a minus 3b by 2b is a rational, root 5 is also rational, right? But we know root 5 is an irrational number, right? Right. This contradicts to the fact that root 5 is an irrational number, right? Why this contradiction has arisen? This contradiction has arisen due to our assumption. Since we have assumed that as a rational number, we have got opposite result right here, right? Therefore, if our assumption is wrong, what is correct? 3 plus 2 root 5 is irrational number. Therefore, our assumption is wrong. What is correct? Therefore 3 plus 2 root 5 is therefore 3 plus 2 root 5 is an irrational. Right, we have completed first exercise, first bit, right? Right. Second question. Second question also is just like example only, but I will explain little bit speed. Right. If we will assume root p plus root q as irrational, sorry, as rational, we will assume if that is rational, a comma b are co-prime numbers and co-prime numbers b not equal to 0, same thing, squaring on both sides. I'm explaining a little bit speed because we have already completed this question, right? This you will get squaring on both sides, you will get assume root p plus root q is rational, right? Root q whole square equal to a square by b square, you will get p plus q plus 2 root p root q equal to a square by b square, and same 2 root p into q pq, and you can write a square minus p minus q, transpose that p plus, and same pq equal to a square by b square and minus p minus q by, here 2 is multiplying, right? Transpose this 2 and this will divide, right? And again, where he in the question he has given p and q are prime numbers, right? If p and q are prime numbers, you will get irrational number only here, since p comma q are prime numbers, you will get irrational number in the left hand side, right? I can guess, right? In the right hand side, for any value of a and b, for any value of a comma b, the value of RHS is rational number, right? For any value of RHS will be rational number, and if RHS is rational number, LHS is also rational number, right? But this LHS, we know that LHS is irrational number, right? This contradicts the fact that root pq is irrational, right? Why this contradiction has arisen? Due to this contradiction has arisen due to our assumption. What is our, that means our assumption is wrong, right? What is our assumption? Root p plus root q is rational, therefore root p plus root q is irrational. where P comma Q are prime numbers.